Okay, so if you were out last time, you might want to watch that video and watch us do, oh yeah, it's the same problem. Watch us do the Chicago problem. The only difference between if you're doing a test for means versus a test for percentages, and is everybody cool with that? Sometimes I got people confused about this word proportion. It's just another name for percentage. The only real difference is the Z star formula we have to use. So last time, if you were here, we just kind of stole from this formula here. We stole this. That is the standard deviation. And how do I know that? Because it's in the right place to be the standard deviation. So we stole that and put it right there. So fundamentally, the Z formula is always the same. It's always my data minus the middle divided by the spread. The formula never changes. Some of you guys might think I'm insane because you're all like, that looks very different from the other one we used. But it's the same stuff. It's the same stuff, just the standard deviation changes if it's percentages instead of means and blah, 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 but it's still the same idea. So, read through this problem and try to see if you can find what the claim is. Focus. Okay. Focus. Thank you. Oh, this is another old one. We're gonna update these bad boys. O's and the Hobbs. Can somebody remind me real quick, whatever the claim is, how do I tell if it goes into the null hypothesis or the alternate? What do I look for? What tells me it's going to go into the null hypothesis, affectionately known as the HO? What tells me I'm going to put it here? What has to be true? Has to have some kind of equal sign, either an equal sign or less than or equal to or greater than or equal to. So what is the claim being made? In English, what's the claim being made? What's the claim being made? Just fully English. What's the claim being made?
That 282 students agree that passing a 4-week stats course during summer is impressive.
Well, that's not a claim. That's what we saw from the survey, right? So it's not a claim. The claim is being made about something we don't know. That we know. I talked to 322 students, and I know that 282 of them said that. It's a known thing. What's the claim that's being made?
The portion of students is different.
Good. A portion of students is different from. So what symbol am I going to use? I'm going to use a little mu or p.
No,
Mu is if it was a mean, right? P. So if it says average or mean, you know you got mu's. You know you got to use a formula with x bar minus mu, blah, blah, blah. Here I know it's all about the p stuff, so I want to use all the formulas with the p stuff in it. So the claim is p. Keep going. What's the claim? In mathish now. Is different from. So what would that be? How do you say that in mathish? Is different from. Does that mean it's greater? Necessarily? Does it mean it's less than? Does it mean that it's equal to if I say something's different from something else? Or are they equal then? Are they equal? Just tell me. Are they equal?
No.
So they are they equal?
No.
So they are not equal, right? That's it. So P not equal to 0.845. Yes?
Is that a new paper?
Oh, yeah. Well, it's not new. It's from last time. It's on the one side we had Chicago stuff. Did you get this one?
Oh, I think that's
Yeah? Okay. By the way, this problem is, I didn't actually talk to 322 students, by the way, just made that shit up, but I have taught stats in 4 weeks in January session. So just imagine this class, 4 weeks, right? So they were insane, and I was insane, and I basically said that the first day, we're all insane. Let's do this thing. It's crazy. Anyway, Okay, so does everybody, what you're looking for is stuff like, we think it's gone up, we think it's decreased, we think it's different, we think it's the same, we think it's less now, we think it's at most this. Those are all things that are telling you what symbol goes here is different than would be not equal to. So where's that going to go? Totally the ha. The ho's got to have an equal sign. This has the exact opposite sign, right? So the claim could be either one of those. How do you tell which one it is? Does it have an equal sign? This one has a not freaking equal sign. So that's got to be the ha. So then what's the ho going to be? What's the opposite of not equal to? Equal to. So the very first step is just, what's the claim? And normally that's good. I might not use the word claim. I might say we feel that, we believe, or I might say the claim. But it should be pretty simple to find what somebody's thinking, what the claim is. Find it in English, write it in Mathish, and then just, does it have an equal sign? If so, I put it in the ho. If not, I put it in the ha. I like it. Now again, I really want you guys to understand, when we created this method, we had to make choices about how to set it up. So there were a lot of different ways we could have done this. So if you're sitting there thinking, why did you guys do this? It's because back in the past, math people were crazy, right? A lot of them drank a lot. You never know. So weird things happen, but we're going with it. So the reason they chose to set it up this way is this will always set up the rejection region, always. So how many tail tests will this be? How can you be not equal to something? You have to be one way or the other to be not equal to something. Does not equal to mean has to be greater? Does it mean you have to be less? It means you could be either. So it's two-tailed. Your sample could go either way and show evidence. That's why it's a two-tailed test. So if this has an arrow in it, it points where the tail is. If this has a not equal to, either way works. So this is a two-tailed test. Yeah. So here's what the ho thinks, right? Which is not a phrase you probably thought you were going to hear in a math class, but I'm sorry. That's what the null thinks. I really want this to fundamentally make sense. If the null is correct, I should get a percentage close to this from a sample, correct? I'm not going to get exactly this because it's just a sample and samples could have variability. But if this guy is right, I should get something close to 0.845. So if I get something far away from 0.845, that is evidence that the actual percentage is not 0.845. That's just it. That's all this is. 5 steps, a lot of shit, a lot of work. But that's all it's trying to say is, was your sample so different that this can't be true? That's it. That's all this is. But all these steps are necessary. What the hell are we talking about? This step is, are we allowed to do something? So now in a percentage problem, who remembers what you have to check? If it was a mean problem, you'd have to check n greater than 30. Or it would have to say it is normal, correct? What do you check for a percentage problem? Does anyone remember? It's not n greater than 30. It's not good enough. NP and?
Greater than S.
Green equal to 5. That's my fault. It's probably, that looks like an S, I know. And I have to check NQ greater equal to 5. I have to check those. Jeff, you can do it. So what is N? 322. What's P? 0.845. I love it. We assume this is right. So we're assuming that P is 0.84. So what's NP? Somebody help me out. 322 times 0.845.
272.0.
And that's definitely bigger than 5. What about NQ? That's going to be, let's see, Jeff, you can do it. 49.91. What is Q, by the way? What is Q? P is 0.845, what does Q have to be? 155, it's gotta make one together, correct? P and Q, no matter what clothes they're wearing, have to always add to be one. So if I know one of them, I know the other one. And help me out, did I get that right? What did I say? I said 49.91, is that right? Nobody's gonna help me, okay. Screw you, Jeff, you're on your own, man, you're the math boy. All right, whatever. So just make sure that's right, you never know, it could be crazy. Holy shit, okay. By the way, real quick, just in case, you can throw this in your calculator, but these two numbers have to add up to be the total. This is basically the expected number of successes, and this is the expected number of failures. So together they have to add up to be 322. That's how I got that answer so quick. Do you have to know that? No. Okay. What does this mean, what we just did? What does that mean? What does that mean?
The distribution is normal.
Beautiful. Distribution normal, so we're allowed to use z-scores. If this was not true, either one of these or both, if they were not true, you can't do anything. So it's z or nothing for percentage problems. Yeah, how we doing so far? Excited, I know, I appreciate you guys keeping it down. Okay. So what do I need to know? So we're allowed to use z-scores, that kicks ass. What do I tell you that we need to figure out the rejection region? What do we need to know? I can use z-scores, cool. What else do I tell you that feeds into figuring out the rejection region? Two things. So do you see how the rejection region is basically the two tails out here? Right, so one thing we need is the fact that it's a two-tail test. So now I know which row to look at on the t-score chart. Right. Is everybody cool with the fact that I just said we're going to use a t-score chart, even though we use z-scores for this problem, right? Why is that okay? On the t-chart, do I find z-score somewhere? Where? You guys are all like, yeah, man. Just.
It says large.
Yeah, at the bottom. So if I stop, I get a t-score. If I go all the way to the bottom, I get a z-score. So it's beautifully set up for hypothesis tests, one tail, two tail. What's the other thing I need? I know it's going to be two tail, but what tells me which column to look at? Alpha, kick ass. Alpha's 0.10, two-tail test. Can you guys please look on your t-score chart and tell me what that z-score is going to be? I keep forgetting to bring my t-score charts.
1.6.
That's the one, yes. You guys get that? Negative one, well, you get 1.645. And again, we're the humans. We have to understand that I have a negative one and a positive one. T-score chart is just telling me the numbers. If you weren't able to find 1.645, let me know. So just to reiterate, what did unusual used to be? The first time we talked about unusual, how far did it have to go to find something unusual? 2 steps. Hypothesis tests, depending on how significant the alpha level, I define unusual differently. In this case, unusual starts 1.645 steps away. That's where unusual starts. So if I find a sample that is in here or down there, that is unusual if this is the real middle. That's why it would be evidence that this isn't the real middle. It's not equal to that if I find something out here. So again, the middle is basically the 0.845. If our sample shows up way out there or way down there, it's evidence that it isn't 0.845. It's so far away from it. So how do I say this in words? If Z star is, how do I get up in here? How do I get right here? What has to be true about my z star? How does it relate to this? You
It's
get in there.
greater.
Greater. Or z star is? How do we get down there? Less than negative 6.45. If that's true, we reject the null, support the ha. So again, the null is the one that thinks it equals this. If it does equal 0.845, I should get a sample close to it. So a sample far away from this is evidence that that's wrong. That's why we can reject the null hypothesis. It needs to do the things that's in here. Okay. And now it's the step that you can sink your teeth into. Right, what was n? 322. X is 282. It's the number of successes, right? So to get the percentage from the sample, it of course would be 282 out of 322. So help me out, what is that?
1.42.
Point, what's that?
It's 1 point.
No, can't be. I think you flipped it. 282 divided by 322.
Oh, yeah, you're right.
Yeah. Right? P hat can't be bigger than 1.
Oh, okay. 8757.
8757?
Yeah.
So 876, okay. So I'm not sure if I said this before, but your p hats have to be at least 3 decimal places. So effectively, you can round everything to 4 places and be safe, right? Does that make sense? Except z-scores. Why do we round z-scores to 2 places? Because the z-score chart only goes out 2 places. But if you want to be safe, just round everything else to 4 places. You'll be completely safe. And now it's just plug and chug. So you guys take a minute, see if you can't plug this stuff in. Where's the only place this number goes in the formula? Where's the only place that number goes? I think I heard you say on the top, yeah, right there. This is the P from the claim. That's the P and the Q from the claim, right? So this is P and Q here, right? The only place that our information goes is right there. That's the only place 0.876 goes. So see if you can't set that up and plug it in your calculator. I'll wait. If you think you get the answer, you're brave, let me know what you got. Not even if you're brave, I mean, just tell me. Who cares? I'm not going to grade you on this yet. Well, there's the answer. But did you get that?
Yeah.
Okay. You got to be really careful. I tried to show you where to put parentheses. Now, if your square root grows, you don't have to put any parentheses in there. But it depends on if you have the newer or the older calculator. You definitely want parentheses are on the top, because the calculator doesn't have eyeballs, thank God. That would be exceptionally weird. So has anybody got that? Yeah,
I got 1.4875.
almost. What'd you put here?
Putting it there, where,
Did you put those numbers there?
Yeah.
Okay, I'm not sure what happened. You almost got it, but not quite.
It's because my denominator was, I shortened it instead of.
no, that's good.
This is a times, by the way, right? Sorry, I'll make sure. So here's what it should look like. So I got 1.54. So there's what it should look like inside. Is that cool? I'm not sure what happened. Do you see what? If not, I'll come take a look. Not a problem. Anybody else get that? You guys all right? Oh, I see. Oh, okay. So what's happening is, if you round numbers in the middle of a problem, the answer's gonna be thrown off with it. Especially when you're dividing by something really tiny, little changes in it will become huge, problems. If you wanna do this step by step, oh, also this is a 6. It's a 6. Yeah. Let's see if that's the only problem. It's a 6. Oh boy, okay, alright, so here, let me show you. So, put parentheses, now put the top in, when it's a 6. Oh, no, okay, alright, sorry, put the whole thing in, put the top in, only it's a 6. Oh, I see, okay. So here's the issue. The calculator needs to know what the top is. That's why I need the parentheses, so that's the top. Because it can't see a big division bar divided by square root. See how you have the little parentheses, just don't close it until the end, so now put the rest of it. 1.5, don't do any more parentheses times. There you go. Kick ass. Yeah. Is everybody else okay? Now's a really good time to tell me if you have any issues, because I'm not gonna help you on the test. Okay. Everybody else all right? Okay. My calculator's not all right. Okay, so we got 1.54. Did we make it far enough away? Did we succeed? Did we make it far? What was far enough away? In fact, you can see what you've written right here, right? Is Z star greater than 1645?
No.
Nope. It's here, isn't it? That's where it is, yeah? 1.54 is right there. So again, if this number is correct, any sample I pick should be close to it. If I get a sample that is not close to this, that's out here, that's evidence that 0.845 is wrong. Did we make it far enough away to show that evidence? No. We're in the middle. We're exactly where it would be if the null was correct. So I can't reject it. I fail to reject. You guys get that? There's a really simple idea at the base of this, but then it gets really lost in all the steps we have to do. I totally get that, but don't lose touch of what the idea is. If the null is right, a sample should show up in here. If the null is wrong, a sample would show up far away. We got a sample that showed up in here, so we can't say the null is wrong. We can't. It showed up pretty much where it should. So we fail to reject. The null fail to support the ha. So, does anyone remember what the hell the p-value is? Okay. Can anyone tell me a really quick way to just tell me, if I wanted to tell somebody where alpha was in this picture, could anyone tell me where alpha is? I have shown it. Alpha is there.
8.45.
No.
No,
It's okay. At least you tried, right? Yeah?
It's the points out, like the black, like
Yeah, it's the shaded parts.
Oh.
Alpha is the area in the tail or tails. So that is alpha. There it is. The shaded part is alpha. Right? Okay. And in fact, alpha is 0.10. So how much is here? In that tail? How much is right there? 0.05. So how do I get alpha? If I just look that there's 5%, I have to double it. Right? You guys with me? If there's 5% in there, what is alpha since it's a two-tail test? It's double that. So, alpha is in the tail or tails of the z-score from the rejection region. The p-value is the area of the tail that our z-score makes. Can you guys get your z-score chart? Figure out what the area is in the tail that 1.54 makes. If you don't have your z-score chart, don't feel bad because I don't have mine either. So I didn't bring mine. Let me know if you get that. Whoa. Oh, I see what it did. Holy shit. Okay, weird. What'd you get, sir?
It's on the positive side, correct?
You need, if you look up positive 154, are you gonna get this area here? No, you're gonna get this area. So you gotta do 1 minus that to get this area, right? Or you could look up negative 154 to be a shortcut.
0.618.
0618?
Yeah.
Okay. So make sure you can see that. 154, double check. You should get 0.9372. Is that what you got first?
What was that?
9382, sorry.
Yeah.
Yeah. So 1 minus that is this. Now here's the weird part. So the p-value is the area in the tail or tails that our z-star makes. This was a two-tail test, correct? So I've got to double that. So the p-value will actually be 2 times 0.0618, so it'll be 0.1236. Okay. So what that means is there was a 12% chance of getting a sample where we did if 0.845 is the real number. Is 12% chance unusual? If something has a 12% chance of happening, is it unusual? No, it's a 1 out of 10. It's even better than a 1 out of 10, right? Something has a 1 out of 10 chance, I wouldn't say it's unusual. Does that make sense? No? Okay. It's sort of like the difference between, if you saw a dude that was 5'6", would you go, whoa, holy shit, can I take a picture with you? Would you? No, because it's not unusual. It's a low probability, but it's not unusual. If you saw a dude that was 4'8", you would be respectful, hopefully, but still, we're human. We don't see that all the time. I'll go, whoa, okay. Right, but not overtly. We're not going to be human. Go, holy shit, look at you. And that would be a little much. But you guys understand what I'm saying? This is not, 12% chance is not unusual. That's why it's not enough evidence to show that the null is wrong. It's not unusual enough. Okay, so. Is everybody cool with me writing these? Can you guys see that that led to these statements, right? So I can immediately write these little statements right here. Remind me, which one was the claim? The ho or the ha? The ha is the claim, correct? So I'm going to use this language. That's how you tell how to write the conclusion. So we failed So we have not found, because we failed, we have not found sufficient evidence to support the claim that, and then plagiarize. The percentage of students who, holy crap, what was it? Who agree passing 4-week stats course. Where'd he go? Is impressive. Is different from, this is a long one, 84.5%. Shit. So we can't say that. Our sample didn't show up far enough away to be able to say, it looks like it is different. We didn't succeed to do that. We can't say it's different. We didn't get far enough away. So two things. The day that I can't read this is the day I retire, so you guys are like, what this is 4 weeks, yes? Okay, so two things. I write horribly, we all know this. But secondly, this kind of sucks, I know. This is a long-ass thing to write, but, you know. Not exactly a compare and contrast paper in English, so it's not as bad as it could be. Okay, so let's do this. Let's take a minute. So I don't want to talk about 10, I'll talk about 10-2 at the end. I just want to focus on what's actually going to be on the test. In case you do 10-2 homework for extra credit, I will have one bonus problem from section 10-2. So if you do the bonus homework, you have a chance to maybe get that right, get some extra points on the test, right? Let's do this. Let's create the formula sheet, and then I'm going to ask you to do specific problems on the practice test first. And then we'll kind of open it up to whatever we want to look at. So again, if you just want to add these to your formula sheet that you already have, that's cool. Or you can just make a brand new little formula sheet. See, where are you? There you are. Okay. Oh man, is anybody gonna work? Let's find out. Okay. So, this test is going to be on chapter 8 and chapter 9. So it's got the confidence interval stuff, and it's got that hypothesis test stuff. So the stuff from chapter 8 was the confidence interval stuff, right? You've got the two confidence intervals for means, and again, the formula tells you, use a T if you only know S. You can use a Z if you know sigma. What else has to be true for you to be able to construct a confidence interval? What's got to be true? It's got to be normal enough. I love it. So in these two cases, n's got to be greater than 30, or they have to say it's normal. And in this case, of course, NQ have to be at least 5. Then you got the two formulas, 3 really, so let me go ahead and put all 3 up here. What does n mean again? Of what? The number of things that are in your sample, or you can say sample size, right? So if I ask you, how many things would you have to survey or whatever, that's going to be one of these formulas that has n equals, correct? Don't make a confidence interval. No, you want to know how many. That's got to be an n equals formula. So you got 2 situations related to these 2 things. And they got one situation related to this one thing. Oops. Okay, so you got, these are all from chapter 8. If I ask you to construct a confidence interval, it's got to be a formula with a plus or minus in it, because a confidence interval is low to high. So I need a formula that subtracts and adds. That makes sense. If I'm not asking you to make a confidence interval, don't use one of these formulas, right? I always get people trying to use these formulas where it doesn't work, and it gets all freaky. The only new formula from chapter 9, hypothesis tests, the only new formula really is the p-hat one. But I'm going to go ahead and put stuff like this. This is how I would construct my formula sheet, right? So it's the same old z-score formula we've been using for z-star if I have a means problem. If I have a t problem, the formula really is the same, except you're going to get this. Obviously, if I'm using t-scores, that means I only have s, so instead of sigma, I'm going to have s. Not a real big surprise. And then, of course, we got the brand new formula. Now, it's on you if you copy a formula down wrong because you couldn't quite read my writing. I know my writing's horrible, but go back, look at the worksheets we've done, double check your formulas, make sure you got it right. For some reason, I always get somebody that puts a minus there or something silly. You know, just be careful. So these three things are for different hypothesis testing. Right, these two are for means. This is if I have to use Z, this is if I could have to use T. This one's for percentage hypothesis test. Yeah.
Is that an S or a 5 on the
Which one, sorry?
the fourth equation?
Yeah.
Under with the 5 and a 5 in or S in?
Oh, these are both S's. How do I make an S? I don't know. That looks weird. Yeah, it does look like 5s. I agree, but those are S's. It's just basically the same formula as this, just not a sigma. It's just an S instead. Yeah. Okay. So, anything that you think should be up here in addition to these? And again, you could bring all your formula sheets if you want to. But is there anything that you think I missed? That's always possible. I'm only human. Now I got this song stuck in my brain. I'm only human after all. Oh, that's not what I want to give you yet. So let's do this. I want you guys to try to do, oh crap and a half, what happened to you? Poor little dude. Try to do number 5, right? Because that's one just like the p-hat stuff we just did. Notice on the test, I will give you something with all 5 steps. So you never have to memorize the 5 steps. So use the 5 steps on this. Are you with me? Use the 5 steps on this. So I'm not going to make you memorize the 5 steps. I'm going to give you at least one problem hypothesis test that has the 5 steps laid out. Where am I gonna put that P equal to?
Uh,
What'd you call it? Oh, P equal to 0.667. Definitely goes in the null hypothesis in the ho because it's got an equal sign. So what's the ha gonna be?
negative 0.667.
No. Whatever the one dude says, these are two dudes, right? I always think about it like two old guys in a coffee shop. Whatever this guy thinks, he thinks the opposite. So this guy thinks it's equal to 0.667, so this guy thinks it's not equal to. So how many tail tests will this be? We're doing number 5 on the practice test. How many tail tests?
Oh, 1.
Nope.
2.
2. So how do you know it's going to be 1 if there is an inequality, and if it's greater, then it's going to be a tail that way. If it's less, then it's going to be a tail that way. It's pointing in the direction. Not equal to means bigger or smaller. That would be evidence it doesn't equal something. Two tail. What do I check to see if it's normal enough in this case? N is 84, right? That's bigger than 30. Is that good? Isn't N 84? Isn't that greater than 30? Isn't that great? Is that what I need there? What do I need to check? Not just N. What do I check?
5.
Something about 5, yeah? Something about 5? N, P, and Q. I love it. So let's see, what's NP? It's going to be 84 times P, which is 0.667. Is that 56 roughly?
Yeah, 56.
Point something?
402.
This is blah, blah, blah. That's very good. So NQ is going to be 28 roughly. What's Q going to be? What's Q? 3, 3, 3. Yes, the reps, these have to make 1 together, right? So this will be, I believe it's roughly 28. Almost, right? It's like 27.9 something. Okay. And that's bigger than 5. You don't have to be that precise, it just has to be bigger than 5. So if you get 100 point, who gives a shit about the point? It's bigger than 5. That's all I need. What does that mean? What we just did, what does that mean?
That is normal.
Normal enough, check. Okay, so that means I can do shit. So if that step actually failed, if you got one of those less than 5, you technically can't do the problem. I will never do that though. Wouldn't that be evil if I made a problem where you didn't have to waste time, if you just realized it's not greater than 5, and then a lot of people are doing the whole problem? That would be so evil. I'm not that evil yet. Right? Give me a few more years. Maybe I'll be that evil. Okay. So what do I need for the rejection region? What's some things? For example, I know it's a two-tail test. That's important. I know I can use z-scores, right? Because of part B, which means I really can just do something.
Alpha.
What's the last piece I need? Alpha? What's alpha?
02.
0.02. So if you look up two-tail, 0.02 z-score on your t-score chart, what do you get for that? I'm a freak, so I got it memorized. Yeah. So double check and make sure. If you look at alpha 0.02, two-tail, so you want to look at the second row for 0.02, and then go all the way to the bottom, you should get 2326. And again, we're the humans. That t-score chart is just a freaking piece of paper. We have to be like, oh, I got 2 of these. One's negative, one's positive. Okay. So, can you shade in the rejection region? It's a little bit of a misleading question, because how many rejection regions are there on this picture? Two, yeah, there's one on that side, one over there. So, and then I just want you to say it in words. If, oh, I don't have much room here. If Z star is, how do we get in here? Less than negative 2326, or greater than
2.3.
positive 2326, we can reject the hope, support the hope. So again, step C just is setting up what enough evidence is. That's enough evidence. If we find a sample that far away, that is evidence that it's not in the middle of the picture, it's actually off to one side. So step D, what is N? 84. How do I get P hat? Out of those 84, how many did we find?
63.
63 out of 84. What is 63 divided by 84?
0.75.
0.75? Neato. Neato. 0.75 exactly?
Yeah.
Okay. Over 28, 7, yeah, okay. So we see that, it's just how to calculate p hat, that's been the same, it's just the number divided by the big number from the sample. It's this part divided by the whole. And now we just plug all this shit in, right? So p hat, we just calculated 0.75, what's p? 0.667. Divided by the square root of 0.667. Oh, scheiße. The root of this. Times, what was it? 0.333 divided by, forgot already, 84. Two nights. 2 months. Which is 1.4. I think it's like 1.68 or so. I could be very wrong. It's a lot to try to do in your head. Oh, okay, not too bad. So let me know if you got the Z star here. You wanna suggest what it might be. So to put it in the old calculator, let me do this again. You have to put parentheses around the top, 0.75 minus 0.667, because the calculator doesn't have eyeballs. It can't tell what the top is. Divided by square root. Now I'm lucky I got a calculator where the square root symbol grows. Square root of 0.667 times 0.333 divided by 84. So I don't need parentheses. But let me do it the other way. Let me remember where this is. Is this the one that makes it do that? Let me see if this makes it do that. Yes, okay, so if some of you guys have the square root and does this, just do not close that parenthesis until you get all the stuff in there that's supposed to be in there. If you close the parenthesis, you come out of the square root. So you should get the same, oh shit. Oh, I left 1 3 off, good job. There you go, same number, 1.61, basically. So, did we make it far enough away? Where's 1.61 in here? Did we make it into here? Yeah, it's over here, isn't it? That's 1.61. We did not make it far enough away. So we fail to reject the hope. Fail to support. Good Lord, Jeff. The hop. We got no room for anything. Oh. We failed. By the way, I do have an answer to you. I think this is written better on it. So the conclusion, how do I word the conclusion? Which one was the claim?
The hope.
The hope. I like it. So I'm going to use this language, not that language. So fail, we have not found. Because we failed. Sufficient evidence to reject the claim that, what was the claim? Blah, blah, blah. The proportion of students, percentage of students who want shorter semesters is 66.7%. By the way, I don't know if you guys know this, but we are shortening our semesters, finally. So next semester, I believe it starts, so we're gonna have a bit of a shortened semester. It won't be, it's normally 16 weeks, right? So now it's gonna be less than that. I can't remember what it's gonna be. But most other colleges have what's called a compressed calendar. We're finally gonna do it also. So all the classes will be like a few minutes longer, but the whole semester will be shorter, so that'll be nice. And then some of you guys are like, well, great, because it's my last semester here. Thanks for doing that. Sorry. Okay. So I know there's a lot of steps, and I think I told you that when I was taught this stuff, there were 8 steps. So I cut that down to 5. These are the only 5 that you really need. And again, when you go to do chapter 9 homework, the book is going to say use the worksheet in the back of the book. You say no book. I'm going to use the 5 steps, thank you very much. And that's how you do the hypothesis test. This way. These 5 steps. So, let me leave it up to you. Looking through the text, we could do this other hypothesis test if you want, or we could do one of these earlier things. I think it might be good to do number 3, but does anyone else have a specific one you kind of want to look at? Or if you're ready for the test, you can just head out. That's an option too, but is there any of these that you'd like to kind of go over together? 4? So the other hypothesis test?
Yeah.
Okay. So I know I don't write it on this problem for some reason, but the very first thing should be, what's the claim? Because then you can tell where it's going to go. So we're creating a new drug, right? Now I got that song in my head, great. That is specifically for statistics students, for their specific thinky pain that happens in the head, right? And of course, why would we want to create a new drug? Because we want it to take less time to work, right? So we're doing a test, just like you would do any test if you create a new medicine, a new drug. Can anyone see what the claim is? I'm being very nice in this problem. I made it bold. Yeah, so how do I say that in mathish? Is this a test about a mean, or is this a test about a percentage?
Mean.
A mean, good. So the claim is the mu is what? Less than what?
16.1.
Good. The sample information will never show up until step 4. Because I would make a claim before I took a sample. So I think that our new drug is less time than the old drug, which is 16.1. Why did I do this? That's silly, Jeff. Oh, too bad. So which one, what does that go in for, the ho or the ha?
Huh?
Yeah, because it doesn't have an equal sign. Now somebody else, what's the opposite of less than? What's the opposite of less than?
Greater.
Almost. I love it. You're like, what do you want from me, man?
Greater.
Something has to be equal to this, yes? If it's not this, it must be the opposite. So the opposite of less than is greater than or equal to. But again, Davis, I appreciate you having the gumption to say something. It makes sense. It's greater than, of course it is, but it's also equal to it. Then, therefore, these two together cover everything, right? That's why they're opposites. Is this going to be a one or two-tail test? Two-tail. Not two-tail. Why one?
Because I don't even know.
In fact, so the ha is always going to tell you. Does the ha statement have something that looks like an arrow in it?
Yeah.
Yeah. Which way is it pointing? That way. One-tail test that way. Because again, if I want to show evidence that it's less than this, don't I need a sample that is less than that? So I only give a shit about that one side. That's why it's a one-tail test. One-tail test. You guys see how to tell that? That's not a big deal. And if there's an arrow in your ha statement, that's where the tail is. If there isn't, if it's not equal to, two-tail test. Because it doesn't matter which way it goes then. All right, try to keep going. Get as far as you can in this problem, and I'll catch up. Now's the time to just try shit. Even if you don't know what to do, just try shit. Because this is the one that's not going to count. Right? Just try something.